Ever wondered how to build a real-time multiplayer space combat game that actually works? Not a simple local multiplayer demo, but a real networked game with Unity gaming services, handling matchmaking, lobbies, and synchronized gameplay across the internet? In this tutorial, we're going to build a complete SpaceWar game from the ground up. We'll use my multiplayer boilerplate package to skip the boilerplate and focus on what makes your game unique, the gameplay. You'll learn how to architect a scalable multiplayer system, synchronize physics-based combat, handle player connections gracefully, and deploy it all with Unity gaming services. By the end, you'll have a fully functional multiplayer game and understand the patterns to build your own. If this sounds interesting to you, then grab your favorite beverage, pull up a chair, and follow along as we build a complete multiplayer SpaceWar game from scratch in Unity 6. Okay, so diving right in, you can see I've got a brand new Unity 6.2 project. I'm using Unity 6.2.6F2, but any 6.2 or higher version should be fine. I suspect, at least, that 6.3 will work. I haven't tested it yet. Now, I have installed a couple of packages from the Unity Asset Store. These are both free packages. It's a 2D Space Kit and free Laser Weapon Sound Pack. We're going to be using some of those in our SpaceWar game. The very next thing we're going to want to do is we're going to want to install my core package from GitHub. So the way you do that is you go over to the web page, and there'll be a link in the description. Oh, by the way, I will put a link in the description for those two Unity asset packs as well. But when you come to this page here, we go down to Installation, Install Core Package Dependency. You can see that we've got this link to our core package, and I'm going to right-click that and say Copy Link. Then we'll jump back into Unity, expand this drop-down, and say Install Package from Git URL, and paste that link in there and click Install. And this will take a few minutes. Once that's installed, we're going to want to go and grab our multiplayer package, copy this link here, go back into Unity, expand the drop-down, install package from Git URL, paste in the multiplayer link, and click Install. So that's done installing, and you notice you don't see anything in our project hierarchy. This is actually installed as part of the Unity package cache as immutable packages, and I'll show you that a little bit later. One thing we want to do next is we do want to install under samples. So we're under our Midnite Oil Software Multiplayer Boilerplate samples. We want to install the Othello complete game. So even though we're making a SpaceWar game, we're going to use some things from this Othello game. And this is also going to install under this Midnite Oil software. It's going to install a menu that we can use to generate our project structure. So let's go ahead and click Import under Samples. And this will show up in our project hierarchy under Samples, Midnite Oil Software 1.9.0, Othello Complete Game. And there you can see it's got that complete project structure. Now, one thing I do want to point out is this game and our SpaceWar game are both going to use TextMesh Pro, and by default, you don't get the TextMesh Pro essentials and examples and extras. So I actually added a couple of menu items to install those. So if we click that, it'll pop up the Import Unity package for TextMesh Pro Essential Resources. We'll go ahead and click that. And you can see it created that folder there. And then if we bring up examples and extras, it will bring up that install window. And those are all installed now. Now, one thing we want to do, if we go to our build profiles and look at our scene list, we can say open scene list. Right now it's just showing this sample scene here. Go ahead and remove that. And then go into the scenes folder, select all three scenes, and drag them into the scene list. And hit Control S to save. And let's just go ahead and open up the Bootstrapper scene. And if you open up this scene, I mentioned how none of the things from the core package or the multiplayer package show up in your project hierarchy. But if you come over here and look at one of these, like say Event Bus, and then we double click the script here, it's going to open up your source code editor. In my case, it's going to be JetBrains Writer. And you're going to get a little message up here. This file is part of the Unity package cache. Any changes made will be lost. And if you want to go and see where this is, it's under Packages, Read Only. If you expand that, you can see there is the Midnite Oil Software Core, right? And then under Runtime, there's the Event Bus, all my music scripts, my settings scripts. All of those things go under this Read Only folder. And also, just like that, you've got the Midnite Oil Software Multiplayer Boilerplate, which has a bunch of scripts and prefabs for our authentication, lobby system, our base class for GameManager and game session initializer and cleanup, the network player, game state changed event, and so forth. All of that stuff can be inherited from, but you can't change the base class functionality. If you want to change any of this base class functionality, then what you need to do is fork my repository, make your changes, and then commit them to that fork, and then install your package from the forked version instead of from the regular version. So now I want to show you one of the coolest tools that Unity gives you for multiplayer game development, and that is multiplayer play mode. So if you open that up, it's going to open up this window, and I'm just going to dock that here next to my console. And we're going to activate a virtual player. So what this will do is it will allow you to play the single build of your game in multiple instances on your computer. It used to be you would have to do a build, run that, and then run another instance in the editor to be able to test your multiplayer game. Now you can do it all right in the editor with multiplayer play mode. And I'm going to move that over to my other screen, switch over to the game mode over here, and then I am going to switch my scene in OBS so I can see both of those. And I think that's probably pretty good enough. And we're going to hit play, and this should let us test our Othello game. And there you see, I've got 2 instances of the game up and running. We'll log on as player 1 over here. And I'm just using anonymous authentication here. I'm going to host a game on this side. And you can see over here, I can join the game. And then I can just click Start. And there you go. The game is up and running. So that is the beauty of multiplayer play mode. Now that we've verified that we have successfully imported the packages and that our demo game is working, it's time to actually start working on our SpaceWar game. Before we actually get into the implementation, let's review the architecture for this game that we're going to make. So I've got this Markdown file here on GitHub. I'll put a link in the description where you can see the actual architecture of the game that we're going to be making. It's a real-time game, which the reason I wanted to make this tutorial is because even though the Othello game is a really good example of how to use the framework, it's just a simple turn-based game. And I wanted to demonstrate how my framework can also be used to make a real-time game. So it's going to be a physics-based game where you fly around and shoot at each other. This is a high-level architecture diagram showing the multiplayer framework, boilerplate package, how it interacts with the Unity gaming services, and then the things that are specific to the SpaceWar game itself. And we'll be going into that in more detail later on. I'll be covering all the sequence that's going on there. You can see the game state flow here. You're initially waiting for players, then the game starts. You start a player turn start, which will go until a player is destroyed or until the time limit for the game expires, in which case you're either going to get a player turned event, end event, or a game over event. This would start the 3-second countdown to basically spawn a new player and start a new player turn start event. Or when the game is over, you can either rematch or exit to the lobby. I covered the integration with the multiplayer framework that I created. So we have our base classes, our game manager, network player, game session, event bus, player registry, session manager, and game session manager. This diagram here shows how when the game is launched, you initialize authentication. We show the login UI. Then you log in either anonymously or with a username and password, depending on what options we configured. You can join or create a lobby, start the game. We will load the game scene, spawn a game manager. When all players are connected, we raise the game started event. So that is the overall flow for initializing and starting a game. I show my custom extensions here, and we're going to go into all this in great detail later on, but these are all the core systems in the game. This is the project structure for the game we're going to build. You see I have a SpaceWar folder at the top of my assets folder. These are the key components in the game, documenting their key responsibilities, and again, we'll go into each of these in greater detail as we actually create those components. The way you play the game, WAD for your movement, and then space to fire. We're going to go into all this later. There's some documentation notes, the design patterns I use, the fact that it is a server-authoritative game, and possible future enhancements that we could make to the game. So if we look at our project hierarchy here, you see we've got our samples here. What we want to do is create our _SpaceWar folder in all of these subfolders. And to simplify this, when you install the Othello sample, you get a Create Multiplayer Project Folders menu item. So if we click that, it's going to, under Assets, want us to pick the folder to create all these subfolders in. Now, we're going to create a new folder here, and we're going to call it _SpaceWar. And then I'm going to select that and click Select Folder. And there it creates these SpaceWar subfolders. You got art, materials, models, music, prefab, scenes, scripts. And under that is a editor and events subfolder, sounds, and textures. So if we go into the scenes folder for our Othello demo game, we can select those 3 scenes and just move them, not copy them, move them into the scenes folder under our SpaceWar. Now this should still just work if we were to build and run this, because Unity is smart enough to know and maintain references to scenes, prefabs, and components when you move them from one folder to another. So right now, if we were to open up multiplayer play mode and actually run this game, it would play our Othello game. So the next step is to actually go into our components that we copied or moved from the Othello demo and remove anything that's specific to Othello and replace it with the components and the scripts and everything that are specific to our SpaceWar game. Okay, so now that we've got our folder structure, I want to pull in some more assets that we're going to use in our game. And I have these up in a GitHub repository that I will put a link to in the description. But basically, it's some art and audio that we're going to need. And we can just download this as a zip file. We'll open up that zip file. And we're going to want the files from this art folder and the files from this audio folder. And these are all either assets that I created using AI or that I downloaded from free sites like freesound.org. So let me just go ahead and move that over there. Now, if you want to actually drag and drop these into your Unity project, you'd either have to unzip these into a folder, or I'm going to show you a little trick, because you can't drag and drop from a zip file directly into Unity. But what you can do is you can say Show and Explore, and that will show you the folder right there. Then we can bring up our zip file, come into here, select all these, and just drag and drop them into that folder there. Okay, and we're going to come up and go into audio and drag and drop them and drag them into the sounds. So if we go back into Unity now, you can see that it's going ahead and creating the metadata for all of those guys. Now we're going to want to configure these a little bit. So if I pick black hole here, and we're going to look at it in the inspector, we want this to be 700 pixels per unit, and we want it to be single. And then we're going to come down here and click apply. This one we want to be 600, single, apply, 550, single, apply, and 1200, single, apply. And the reason we're doing that is because, I generated these with AI, and in order for them to be the correct size on the screen relative to each other, I had to tweak their pixels per unit a little bit. And these are the images that we're going to use for the player ship, and we're going to randomly assign one of these to the player when it's spawned, and so we want them all to be relatively the same size. They're going to be children of the actual player object. So let's go ahead and make that single, apply, single, apply, single, apply. Okay, so that's all of our art. And I think we should be fine as regards sound. So this is going to be what we're going to play when a ship blows up. And this is going to be what we play when the engine is thrusting. And that's going to be assigned to a prefab component that we're going to use for the engine thrust component, which we'll put one for every. So there's going to be an engine thrust component that can have multiple subcomponents that are actually the visual effects for the thrust. But the whole thing can be turned on and off. So when you're thrusting, you'll display it and play the sound. And then when you're not thrusting, it'll be hidden and the sound won't play. Okay, so let's make the first customizations to our game. We're going to go into our scenes. And we're going to additively add the main menu scene. Okay, and right now this, of course, is our Othello scene. And what we're going to want to first do, we're going to take a look at our camera, and we want to change some things on our camera. For one thing, we don't want it to be positioned up. We want the Z position to be -10, and we don't want it to be rotated on the X-axis. Let me just take a look. We want it to be an orthographic camera. And I believe all these other settings are good, except we want this to be a solid color black. Okay, so that gives us our camera settings. We don't want this main menu background here. This was a mesh that I had created, a mesh renderer, and I had created this overlay using the Othello board, basically. We're going to get rid of this whole thing. We don't want that. Instead, under our canvas, we are going to create a background. So I'm going to say UI image, and we're going to call it background. And I'm just going to drag it up to be the first thing under the canvas. And for our image, we're going to use space background 1. And we want it to stretch to fit the entire screen. Actually, now that I think about it, I want to use space background 2 for that. Okay, I like that. Now we're going to change our title text. And that reminds me, I don't want to use this font. So we're actually going to create a new font. We're going to go over to this site, 1001freefonts.com. We're going to search for Arcade. And we're going to download this Arcade font. And I'm going to open up that zip file. And I'm going to come into our SpaceWar folder, right-click, create folder. There we go. And we're going to say Fonts. Double-click on that and say Show in Explorer. So now we've got our Fonts folder here. I'm going to go ahead and go in there and open up our zip file. And drag that arcade.ttf file right into there. Go ahead and close both of these windows. So now we've got this TTF. We're going to right-click on that, and we're going to say Create Text Mesh Pro Font Asset SDF. So now we've got this beautiful arcade font. Coming back into our game title text, I'm going to scroll down here and drag that into our font. And we're going to set this to SpaceWar. But I want that to be quite a bit bigger. And I want to move it down a little bit. Maybe something like that. Now, the other thing that's going to happen, though, if we were to test this and actually run our game, the script, the main menu UI script here, it's actually going to overwrite the contents of that title with whatever our session name was. Like if I created a game and I called it Greg's Game, that's what it would put in there. And that's not what we want. We want it to be SpaceWar. So we need to override that default behavior. Now I could derive from main menu UI. I could make this I would have to have in my package made this virtual, which I didn't. So we'd actually do a new late update so that we execute our derived classes late update instead of this. But we're not going to do any of that. We're going to cheat. And I'm going to create another Text Mesh Pro field. So we're going to go into UI, Text Mesh Pro, and I'm just going to call this game name text. And then in our script, where it's looking for game title text, I'm just going to give it game name text. And I'm just going to hide that field. So it will change that text, but we won't even see it. And then this one will remain unchanged. The other thing I want to do, since this background is a UI element, it's going to get displayed over top of our game. Because we're going to load we're going to have a new scene here. We're actually going to rename this. This scene is going to be our SpaceWar scene. We're going to load that additively, which means that any UI elements would display over top of it. And what we want to do is hide this when the game actually starts. We're still going to see our title, but we don't want this background. So the way I'm going to handle that is I'm going to create a new empty game object, create empty network UI sync. Oops. Delete that duplicate. And I'm going to move this all the way up under the background. I don't want to actually be under the background. I want it to be under the background. And we're going to create a script. So I'm going to come in here, I'm going to right click, create, scripting, mono behavior script, network UI sync. And we're going to go ahead and open that up. And you know what? I think I actually want to call that UI network sync. So I'm going to rename this UI network sync. And that should also change the file name, which it did. I did F2 to do that, by the way. So now I'm going to hit Control A and I'm going to paste the contents of this script. And what's going to happen is we're going to assign this in the inspector. This is going to be our background image. We're going to subscribe to these events using our event bus. When those events fire, we're basically just going to call an RPC, which is a remote procedure call. This is going to be called by the host, and it's going to tell the clients to hide that background image. I'm going to do the same thing for the on game state changed event. If we get a game started or player turn start, we're going to do the same thing. And the reason I handled it in both of these events is I just want to cover my bases and make sure there's never a situation where the game is playing and we're showing that background image. You've already created a game, you've already joined it. We just want to make sure that that thing goes away. And this is interesting. Reiner is telling me that we can, instead of doing an implicit check for Unity object lifetime, we can do an explicit check because this comparison to null is expensive. And so if I was to select that and look at the little light bulb here, sometimes you have to do this more than once. Yeah, so we get this convert to explicit Unity Engine object lifetime check. So now we don't compare it to null, we just say if, and this will evaluate to true if it's not null and false if it is null. And then we can also invert this if and do an early return as a guard clause to reduce nesting. So instead of having this if and everything nested under the if, we just invert the if in return. And then we're going to do the same implicit or explicit lifetime check. Like so. All right, so let's go back out into Unity, and we're going to let that compile. And I'm going to select that network UI sync, and I'm actually going to rename that because I want it to be UI network sync. And then I'm going to drag this guy onto him. Oh, and so Unity is yelling at me. So this script derives from network behavior. And a network behavior requires a network object, and Unity will go ahead and add it for me. So there we go. We want to assign our background image, and that is ready to go now. So if we were to run this, when we start the game, or actually when our menu is displayed, we'll see this background here. I think we're good to go ahead and test this. I'm going to remove this scene, and I had disabled our virtual player. I find that if I leave this enabled and I make changes in the game, the virtual player instance won't always pick up the changes. And so before I make changes, I usually just disable that. So we'll go ahead and let this activate. And I'll switch over to my MPPM scene in OBS so that I can record and capture both instances. And we'll hit play. So we should get a new menu screen, but then when we start the game, it should actually start Othello. So you see our new screen, SpaceWar. Player 1, Player 2, Host, Join, Start, and it says SpaceWar, but it is actually Othello. Okay, and if you're wondering why we didn't see the board when we were testing that, it's because of the changes we made to our camera in our main menu scene. The other thing I want to do is, if you look at our NetworkManager, you can see that we're using an Othello player as our default player prefab. And then this Othello network prefabs has some things that we don't want to use in our SpaceWar game. So we're going to start making some actual changes for our game. Starting with this NetworkManager, we're going to create a new player. Instead of an Othello player, we're going to create a SpaceWar player. So here under prefabs, you see we've got this Othello player. It's got a network object, and it's got an Othello player script. So what we're going to want to do is we're going to go back to our bootstrapper scene here. We are going to go to our scenes. We're going to add our main menu additively. And then we are going to add our SpaceWar scene additively. Okay. We can start ripping out things from this scene that we don't need. So we know we're not going to have a table. We know we're not going to have a board. And we're not using Quantum Console. That is a really cool asset. If you want to add it to debug your multiplayer games, you can add a Quantum Console. This will let you access the console at runtime in a build. So even if you're running on itch.io or someplace in your browser, you could pop open that console and see your debug statements and stuff. But you can also enter commands. If you've ever played a game like Doom or any game that has a console that you can pop up and enter cheat codes, even Minecraft would let you do that. You can give an idea what Quantum Console will let you do. But we're not using that. If we look at our UI, we're not going to have a chip image, but we are going to have our player name and score. They will be positioned in a different place. We are going to have a game over panel, but we're not going to have a pass or resign panel. This is not a turn-based game where the players can pass or resign. We are going to have get ready text. Now I'm going to give me some room here to work, and I'm going to create an empty game object. And what we're going to do, I'm going to move this down into the SpaceWar scene. What we're going to do is we're going to create our prefab for the SpaceWar player. So the first thing we want to do, we want to rename it to SpaceWar player, and we want to add a network object to it. So there we go. And I want to make sure that its ownership is set to distributable, so that's good. We're going to give it a network transform. And we are going to synchronize the X and Y position, but not the Z position. And we're going to synchronize the Z rotation, but not the scale, and not the X and Y rotation. The authority mode will be owner. So players will move their own player. And I've turned off interpolation, but we are going to use half-point precision. Okay, I think that's good for our network transform. Okay, we also want to add a rigid body 2D to the player. We want it to be dynamic. We want it to be simulated. We can leave the mass fine. We do want to have a little bit of linear damping because we are going to be using physics for the movement, and we're going to apply force to make it move through space, but we want it to have a little bit of drag, basically, so to slow down over time. And we definitely don't want any gravity scale. We don't want this guy falling. Collision detection should be continuous, and we are going to freeze the rotation on the z-axis because we're going to be manually rotating it through the transform, not using physics, and we don't want it to accidentally rotate if it bumps into something. I think that is good for our rigid body 2D. Now, one thing I do want to do is I want to create some layers. Now, we are by default, we're not going to assign the layer in the editor because we're going to have different layers for player 1 and player 2. And so basically what we want to do is assign that programmatically, but I still want to go ahead and create the layers that we're going to use. So we'll drop this down and we'll say add layer, and I'm going to create player 1 and player 2 and player 1 projectile, player 2 projectile, and we're going to have a GravityWell. So those are our physics layers. So if we go into our project settings, physics 2D, we've got this collision matrix. We want to go ahead and disable all of these. Now, player 2 should interact with player 1 and player 1 projectile and with GravityWell. So, boom. So the GravityWell will also interact with player 1 and player 1's projectiles. Player 1 will interact with player 2 projectile, GravityWell. Let's see. Yeah, and player 2. All right, that should be all of our physics interactions. And like I said, we're not going to assign these in the inspector. They're going to be done programmatically. Okay, so we are going to add a few scripts to this. We're going to have a SpaceWar player script. So come up here to scripts, create scripting, mono behavior script, and we will call this SpaceWar player. And I'm going to open that up. And as per usual, we're going to paste all of the code in for this. Now, some of these things don't exist, and we're going to get compiler errors until we fix all of these. But basically, we're going to have some serialized fields that we're going to assign in the inspector. So we're going to be having our visuals. This is going to be an array of fighter prefabs, which are the models with the colliders for the fighters in our engine exhaust that we're going to assign to each player randomly. And after we assign one, we're going to save it off in this variable here. This IDestroyable interface is what's going to allow these guys to be destroyed. The SpaceWar GameManager is a reference we're going to get so that we can basically access some things on the game manager as we need to. When this player is spawned, if we're the server, we're going to manually or randomly assign one of the fighter prefabs to it, and we're going to set its layer based on which player we are, player 1 or player 2. We are going to subscribe to the on value changed for the fighter index. So this is how we keep track of which fighter we are in that array of fighter indexes. If we are not the owner and we don't have a player input, we are going to disable player input. And we're checking our connection ID to see if we're outside of the list of spawn positions. So one of the things we're going to assign in the inspector is an array of spawn positions. So if you're player 1, you're going to spawn on this side of the screen. If you're player 2, you're going to spawn on that side of the screen. And then respectively, you're going to be facing this way or facing that way. Okay. So assuming we pass that validation, we're going to set our spawn position based on our connection ID, which will either be 0 or 1. And also we're going to specify our rotation based on what we saved in the serialized fields for our connection ID, 0 or 1. We're going to set our position and our rotation using the spawn position and spawn rotation. And then we are going to spawn the fighter. We have a ScreenWrapper component that is basically what we're going to use if we go off one side of the screen, we want to come back in the other. So if we don't have that, we want to add that component. And we're going to subscribe to the game state changed event. When our fighter index changes, we basically want to destroy and respawn a new fighter if we have a different image than we had before. We're going to set our layer based on our connection ID to be either player 1 or player 2. Spawn fighter basically gets the fighter prefab, and then we are going to instantiate that prefab, set its layer to the appropriate layer, and disable its visuals. When this despawns, we're going to unsubscribe from the fighter index changed event, unsubscribe from the game state changed event, and call the base class on network despawn. So we are deriving from the network player base class, which is in our boilerplate package. So there's a lot of stuff that we inherit from that package. We're only overriding the things that we care about in our game that are specific to our game. When the game state changes, depending on the state, we're going to do different things. Like if the game is started or restarted or we're waiting for players, we want to make sure we cancel the invoke of any enable ship visuals calls. And then we are going to reset our spawn position and make sure that our visuals are turned off. If a fighter gets destroyed, which will trigger the player turn end event, in that event handler, we want to make sure we cancel the invoke of any enable ship visuals calls. We want to turn our visuals off, reset to spawn position, our initial spawn position. And when the player turn starts, just to make sure, we're going to reset the spawn position again, and then we're going to invoke the enable ship visuals with a ½ a second delay. We just want to do this to avoid any latency issues that might cause this to get called before he's in the correct position and the states are correct. Enable ship visual just basically calls enable visuals on the fighter visual that we are assigned to. Resetting our spawn position. If we have a rigid body, we're going to kill any linear and angular velocity that we might have had. So if the ship was moving or turning, we want to make sure we zero that out, so when you respawn, you're not still moving. And then we're going to reset our position and rotation to the spawn position and spawn rotation. Destroyed target is coming from this IDestroyable interface. Basically, when you collide with something that can destroy you, it's going to get that IDestroyable component off of the collider. And then it's going to call this method, in which case you will, if you have an explosion prefab, you will instantiate it. And we will do network spawn on that explosion so it gets spawned to all the clients. And then we're going to tell the game manager, hey, we died. And that's why we grabbed this game manager reference. So that's pretty much everything for the SpaceWar player. We want to start implementing the things that we need. So we know we need an IDestroyable. And so the easiest way that we can do this is come down here, and I'm inside my namespace here. So you see namespace Midnite Oil Software Multiplayer SpaceWar. What we're going to do is we're going to say public interface IDestroyable, and then I'm going to select that, and I'm going to hit Alt-Enter, or it might be Alt period or Control period in Visual Studio. I can't remember, but basically we want to just move this to its own file, okay? So it's actually in the namespace. That's why I do it this way, because it automatically puts it in the same namespace that I was in here. So if we go back to the top of our file, you can see we no longer have a compiler error for IDestroyable. So now we want to add our fighter visuals. So we'll say public class fighter visual. And I'm just going to leave that empty, move it to its own file. And then I'm going to paste that code in there. And it's yelling at me because I need to include missing references. And so that all looks good. There'll be several things that we will assign in the inspector for those prefabs, but for now, this is enough to satisfy those compiler errors. So for the fighter visuals, you're going to have a renderer, a game object for the exhaust that we will display when you're thrusting. This will also have an audio source that will play that thrusting sound. A collider to see if we collide it with something. And then the muzzle position where we want our projectiles to come out. So enable visuals basically checks to see do we have a ship renderer. If we do, enable it or disable it depending on the value of this parameter. Same thing for the collider. And if we are not enabling, we want to set the exhaust to be inactive. So the reason we're not passing in enable here is we don't want to automatically enable the exhaust when we enable the visuals because they only want to be displayed or enabled if we are actually thrusting. There's a public method called showExhaust, which will, if this is true and our renderer is enabled, we will set active. And then the muzzle transform, this is just a expression body method that gets our private member variable as a public property. What other compiler errors do we still have? SpaceWar GameManager. So let's go down here, public class SpaceWar GameManager. I will move to its own file. Okay, actually before we paste in the code for this class, let's jump over to our architecture diagram and take a look at this component, the SpaceWar GameManager. So it's got a couple of network variables, actually a network list and a float for the time remaining. So you can see its core responsibilities are score management and time tracking. So the game is going to have a time limit, and when that time limit expires, the game's over. There's also a countdown between rounds, so every time a player gets destroyed before we start a new round, it'll pop up a little message that says get ready, and this handles that countdown timer. And also, this is where we orchestrate our game state and check to see if somebody won the game. So I'm going to select all and paste in the code for this game, and we'll just walk through it real quick. This derives from our base class Game Manager, which is in our package cache. So as you saw, we've got our network player, network list, or list of network players. This is actually wasn't shown in the architecture diagram, but we do maintain a list of players in the game. We maintain a list of their scores, and we maintain this network variable for the time remaining. And then we have local to this class the turn start timer, which we can instantiate from our timer pool and subscribe to the on timer stop event if we're the host. If we're not the host, we just exit out of here. So if we're not the server, we return. If we're not playing, we return. If there's no time remaining, we return. Otherwise, we decrement the time remaining by time.delta time. This keeps it frame rate independent. If we are now out of time, we will continue on down here, set the time remaining to 0, and change the game state to game over. This, if there's still time remaining, we're just going to exit out and not fall through here. That's one of those early exit guard clauses like we saw earlier. So we override some methods from our base class. When a player joins the game, we get their SpaceWar player component and display an error if he's not a SpaceWar player. This should never happen. This is where we handle game state change events on the server. So we're the server, we get a game state changed event. Depending on what the game state change event is, we're going to do some certain things. If we're waiting for players, then we're going to set the game time limit to time remaining and set the isPlaying value to false. If the game is restarted or started, then we want to clear the scores and we want to set those in the scores network variable list. And then we want to start the turn start countdown. When we get the player turn start event, we set isPlaying to true. If a player gets destroyed, a player turn end event is going to get fired. We check to see is game over. If it's not over, we're going to set isPlaying to false. We're going to delay for a quarter of a second and then fire the game over event. Otherwise, we're going to start the turn start countdown again. So starting the turn start countdown, just call start on the timer. When that timer is complete, we set the game state to player turn start, and this just waits a quarter of a second just to avoid any synchronization issues. The way we check to see is game over is we're just checking the current state to see if it's game over. All right, there is a rematch event that eventually will get called from our UI if they choose to rematch after the game is over. Clean up session call. We're only calling the base class. We're not doing anything special in our game. If a player dies, then we want to get the index of that player from our player list, display an error if he's not in there. It should never happen. We want to get the scoring player's index, which is basically the player that didn't die, and we want to increment his score. And then we're going to set the game state to player turn end. And that's going to fire that event, the player turned end event. Let's jump back into our SpaceWar player script and see what else it's complaining about here. ScreenWrapper. So this is a component that's going to get added to the ship so that if the player goes out one side, he comes back in the other. So let's do like before. Go to the bottom of our script, public class ScreenWrapper. We will hit Alt-Enter or Control-period and say move to ScreenWrapper.cs. Select everything and paste in that code. So real quickly, we'll go over this. We're going to save off our camera, the bounds of the screen, the ship's width and height. So here in Start, we cache our camera. Go ahead and refactor this to use explicit lifetime check. We're going to calculate our screen bounds and then calculate the object size. So we take the camera, and depending on whether it's orthographic or perspective, we're going to do some math to figure out the size of our camera. Now, it's always going to be orthographic in our game, but just in case you wanted to reuse this in another game that maybe has a perspective camera, you can use this math here. Same thing with the object size. We're going to get the renderer off the fighter. Let's go ahead and do a nice little refactor here. And we're going to calculate the width and the height if it has a renderer. If it doesn't have a renderer, we're just going to default it to 0.5 units. Now in late update, we want to get our transform position and initially say we have not wrapped. We're going to compare our positions X to the screen bounds plus our object width. So if we're over the right edge, we're basically going to take the negative screen bounds minus object width and assign it to our X position. And then we're going to set wrap to true. So we did indeed wrap. Same thing for going off the left side of the screen. We're going to come back in on the right. And vertically, we do it on the Y axis. If we wrapped, then we take that new calculated position and we assign it to our transform position. Okay, let's jump back into Unity and expand our SpaceWar scene here. And we've got our SpaceWar player. We are going to go ahead and drag the SpaceWar player script onto there. Okay, so we got our network transform, we got network object, we've got our rigid body 2D, we've got our SpaceWar player. We're also going to want eventually a fighter script, which we have not created yet. And we're going to want eventually the Attractable script as well, because that can be attracted by GravityWells. And we have not created our explosion prefab yet. That will go here. So before we fill in a lot of these things from the SpaceWar player script, we want to go ahead and start working on a prefab for the fighter. So we haven't even started saving our prefabs yet. I could go ahead and drag this into prefab, but then I would have to keep remembering to apply those to the prefab whenever I make changes. So I'm just going to hold off on doing that for now. And what I'm going to do is under SpaceWar player, I'm going to create empty, and I'm just going to call this fighter 1. And that's going to be one of the 3 variants of fighters that we can assign to this player. I want to, on that fighter prefab, have a sprite renderer. And then for its image, I'm going to go into art and I'm going to drag fighter 1. Let's temporarily in our main menu disable our background. So there you can see our fighter. We go over to game scene. You can see him there covered up by the get ready text. And I'm going to temporarily turn that off just so we can see what's going on there. Okay, so on the fighter, we're going to want to add a polygon collider 2D. And you can see that nicely outlines the shape of that fighter. This collider is going to be set to isTrigger. And then we are going to drag the fighter visuals script onto him. So the renderer we can just drag from right here. We need to create an exhaust object, and that's also going to be a prefab. We can drag our collider down to here, and we're going to create a muzzle transform. Let's go ahead and do the muzzle transform first. So we're going to right click, create empty, and we're going to call this muzzle. And we're just going to drag that up in front of the ship. And that's where our projectiles are going to come from when we fire projectiles. All right, next we want to create an empty and call it exhaust. And we're going to add an audio source. And then for the audio file, we're going to drag engine thrust into there. And I'm going to set the volume to about 0.5. We don't want the engines to be too loud. So now when we're thrusting, when this is enabled, this will play, and it will play on awake and it will loop. All right, so next we want to add some effects for our engines. There is actually, if we go into the 2D Space Kit, I'm going to hit Control S to save my scene. If we go into the scene here, 2D Space Kit example scene, and hit Demo, we get a very cool scene where you got a ship. We could have just as easily used the ship from this demo scene. And if you want to, that's fine. In fact, there are a ton of ships in here to choose from if you want to use some of them instead of the ones I put in my GitHub. But getting back to the problem in hand, there is an engine that has a trail renderer and a particle system. And it looks really cool when this thing is flying around. So what I'm going to do is I'm going to take this guy here. I'm going to go up to my project hierarchy, and I'm going to drag it into our prefabs folder. So now we have an engine prefab. If we go back to our scenes, we'll go back to Bootstrapper. I don't want to save the demo scene. I want to additively open the main menu, and then I want to additively open the SpaceWar scene. What we can do now is we can take that prefab for our engine and we can drag it. Actually, I want to expand this and I want to select exhaust. We can drag that engine prefab to the exhaust and then we can duplicate it. So picking this engine here, let's just position it somewhere around there. Okay, and then this one somewhere around there. So let's take a look at some things on here. On our transform, I definitely want that to be -1. Those all look good. Oh, okay, that looks good there. Yeah, so both engines look pretty good right there. I think this one's a little bit higher than the other one. So let me come down here. I think that looks pretty good. All right, so that pretty much does it for our engine. And now we can take the whole fighter, and for muzzle transform, we can drag muzzle right there. And then for exhaust, we can drag exhaust. And we have a prefab for fighter 1. We still need to create the fighter script that will live on the player. So let's go ahead and do that real quick. We're going to go back into scripts. I'm going to pick fighter visuals. I'm going to go to the bottom of the screen, and I'm going to say public class fighter. I'm going to alt enter, move to fighter.cs, select everything, and paste in this code. So let's take a look at this. So we have some serialized fields for our speed and our turn speed and thrust speed. We have our weapon system, so we need to create a player projectile. We have the rate of fire, so there'll be a delay in between shots. You can't just fire as fast as you can press the buttons. We're going to save off our transform, our rigid body. There's a network variable that we can synchronize across the network about whether or not we are thrusting. And that's only going to be used to turn the visuals on and off, because the server is going to handle moving the player. We have our rotation input. We're going to get a reference to our fighter visuals. We're going to have a next fire time that's going to be based on our fire rate delay here. And then we also want to know the projectile layer. So we're getting a reference to our game manager. And I made a getter here that will, if that's null, try and find it and then return it. In awake, we cache our transform and rigid body. We also set our local position and rotation to be 0 and quaternion identity. In on-network spawn, we are going to call this initialize method. We get our fighter visuals. If we're not the server now, we return. Otherwise, we get the owner client ID from our network behavior. And then we, based on whether we are player 1 or player 2, based on whether our owner client ID is 0 or 1, we're going to set our layer mask. So if we're player 1, this is going to go on the player 1 layer, or the player 1 projectile layer. And if we're player 2, it's going to go on the player 2 projectile layer. So this gets set at runtime. In update, if we're not the owner, we return. If we don't have a game manager and we're not playing, return. Otherwise, we want to handle legacy input. Legacy input is still using the new Unity input system, but we're not using action maps. That's all this quote-unquote legacy means for legacy input. In late update, if we have visuals, we want to show the exhaust component based on whether or not thrusting is true. And this gets synchronized across the network by that network variable that we created right here. All right? And only the owner can write to this variable. In fixed update, if we don't have a rigid body and we're not the owner, we just bail out. Otherwise, we want to handle rotation and handle thrust. So in handle legacy input, we're basically checking to see if we press the A key or the left arrow key. And if we did, we're rotating in the negative or in the positive direction. If we're pressing the D key or the right arrow, then we're rotating in the negative direction. And then to determine whether or not we're thrusting, we're just checking to see if the W key or the up arrow is pressed. So the controls for this are A and D and W, or left, right, up. And then the space bar is used for fire. This is an RPC, remote procedure call, that we're going to send to the server. And we basically check to see, have we exceeded our next fire time? And if we have, then we check to make sure we have a prefab for the projectile and that we also have a visual for the muzzle transform. If we don't have either of those, we're going to display a warning and exit. We instantiate our projectile, which doesn't yet exist, and then we get the network object off of it so we can do a network spawn on it, so it gets spawned over the network. We get the player projectile component from it, and then call initialize projectile on that, and we'll go into that when we create this class, which we're going to do next. All right. If we couldn't get a network object, we're just going to destroy that component. Handle rotation, basically we check to see what our rotation input is, and then we take our current rotation, which is just the Z from our rotation and the Euler angle, and then we calculate what our new rotation should be by adding in the rotation input times our turn speed and then scaling it by fixed delta time. And then we just assign that back to our transform rotation. So we're not using physics for rotation. We're just manually rotating the transform. For thrust, we're basically getting our thrusting value. And if we're not the owner and we're not thrusting, we just bail out. Our thrust amount is going to be our thrust speed scaled to fixed delta time. We calculate the amount of force we want to apply from that and then apply it to our rigid body. We want to check and see if we collide it with something. If we're not the server, we just ignore collisions. That's why those colliders are set to is trigger too, so we're not going to bounce off things. But we do want to know if we hit something and we're the server. And we look for that IDestroyable interface on whatever it was we collided with. And if we got one, we call destroy target on it. And if we didn't find it on that component, we look at that component's parent to see if it has an IDestroyable interface. And if it does, we call destroy target on that. So that's it for the fighter. Now let's go ahead and create a player projectile class. All right, enter, move to player projectile, select everything, and paste the code. Let's look over this real quick. So we have our lifetime. This projectile is going to last for 1 second unless we change it in the inspector. It's got a speed of 20. We have a Boolean that says whether or not we're destroyed. We grab our rigid body and transform and awake. In update, we check to see if we're destroyed or if we're not the server. If either of those is the case, we're going to return. We get our position and we add our speed scaled by time.delta time. So this is not using physics either. This is just moving by directly changing the position on the transform. On network spawn, If we're the server, if we're not the server, we just want to destroy this projectile. If we don't have a rigid body, I'm going to convert this. If we do have a rigid body, then we want to set our linear velocity by taking transform up and multiplying it by speed. So initialize projectile. If we're not the server, we bail out. Otherwise, we're going to set our layer, which we're passing in. We're going to try and get the collider component, and we're going to enable it. And on trigger enter 2D, we want to look for, again, that IDestroyable interface. And then if we have one, we want to call destroy projectile. Well, actually, if we don't have one, we're just going to destroy ourselves in return. Maybe we hit the black hole, which we can't destroy. Otherwise, we're going to call destroy target on whatever it is that we hit. And then we're going to destroy ourselves. And destroy ourselves basically sets destroyed to true. And then if we have a network object, we're going to despawn it. Pretty simple stuff. So now we need an IDestroyable interface. Okay, so I'm missing this reference. So let's come over here and say import missing reference. And there we go. And it looks like all of our compilation errors are resolved. And let's see, before we go and flesh out the rest of those prefabs, I want to create a couple more scripts that I know we're going to need. I just realized I didn't put this in a namespace. And obviously you don't need public in front of namespace. Okay, so now if I go down here and say public class GravityWell, I should be able to move it to its own file. And then paste in the code. So we need to create an attractable. So basically this guy's going to have a gravity strength, a gravity radius. It's going to only affect objects on certain layers. And it's going to rotate. So there's going to be a visual model associated with it that will rotate. And then we have this read-only list of attractable objects, which we're going to go and find some when we become active. But we're also going to have a public method by which any attractable object that gets spawned can register and unregister with us. So basically, in update, we're going to rotate our visual. Then if we're not the server, we're just going to return. Otherwise, we're going to iterate through all of our registered attractables, and we are going to attract them using our gravity strength, gravity radius, and our position. And so this attract method is going to be on the attractable object itself, and it's essentially going to apply force towards us based on these values here. If something collides with us, we want to see if it's destroyable, and if it is, we want to blow it up. And put this in a namespace as well. Move that to its own file. And paste in that code. And put it in a namespace. So let's take a look at the attractable. We have a rigid body, which we will grab in a wake. When we're spawned, we're going to register if there's any nearby gravity wells. We're only going to have one, but hey, why not support multiple ones, right? Maybe your imagination can run wild and you can have multiple black holes in your scene. When we despawn, we're going to unregister. The attract method, which is going to be called by the gravity well, takes the gravity strength, gravity radius, and the well's position. If we're not the server, we should just return. This should never get called, but if it does, we just want to bail out. We want to take our current position, calculate the direction to the well, calculate the distance to the well, and then figure out how much force we want to apply by calculating a fall off and a force magnitude. And then we are just going to add force if we have a rigid body. If we don't have a rigid body, we're just going to manually adjust the position, taking the force times time that delta time. Now, projectiles don't have a rigid body, but the player ship does, and I want the gravity wells to attract both, and that's why I'm handling both of these cases here. To register with a nearby gravity well, we're just going to go find them, and then we're going to call register with gravity well and pass in our network object ID. And this is how we unregister from them. The server RPC is what's going to actually register with them on the server. So this will only happen on the server. The server is the only player, for lack of a better word, that's going to maintain a list of attractable objects, because it's the GravityWell on the server that's going to actually attract them, and then their position will be synchronized across the network. Let's jump back into Unity, and we're going to start fleshing out our prefabs a little bit more. Let me collapse that for a second, and I want to create an empty game object, and I'm going to call this projectile. And I'm going to drag this down into the SpaceWar scene. We're going to need a few things on this projectile. And actually, you know what? I'm going to delete this. I think what I'm going to do, instead of just creating that as an empty, I'm going to go into our 2D SpaceWar kit and prefabs, and I'm going to drag this projectile sharp into our scene. And I'm just going to rename it projectile. And we want to make sure our collider is trigger. It is. Our sprite renderer is that. So yeah, it's a pretty cool looking projectile. We're going to be getting a rigid body, which I'm going to set to kinematic. And do I want to change anything else on that? I think this is all fine. What else do we want to add there? We've already got this projectile script, but I think I don't want that. We're going to use the trail renderer. We're going to add our own script. So if we go into our scripts folder, PlayerProjectile, I'm going to drag that into there. Oops. It needs a network object. Yes, do that. Okay, so now our lifetime is 1, our speed is 20, and I'm actually going to change these values. I should have changed these in the script, but a little trial and error made me realize that 20 was way too fast, and 1 second lasted so long that I could actually, when we start the game, I could just fire and immediately hit the opponent before they had time to get out of the way. Actually, that's not going to happen anymore because I'm going to put a black hole in the middle. But still, I think those speeds and lifetime is better values for that. We're going to want to add our ScreenWrapper component, and we're going to want to add our Attractable component. I think that's probably all good. Oh, except I do want to set the layer. We'll just default it to player 1 projectile, even though it's going to get set programmatically at runtime. And I'm going to drag this into our prefabs folder. And I'm going to delete that. Okay. And we want to take our fighter prefab and we want to add our fighter script to it. And how do those values look? And I actually don't want the fighter script on the fighter. I want the fighter script on the player. So that looks good, that looks good, that all looks good. We need our projectile prefab, so we go into our prefab folder and we'll just drag that right in there. So I think that is good. We go back to our SpaceWar player. For our fighter prefabs, we can just go ahead and drag fighter 1 in there for now. Now we are going to fill in some of these values here. For spawn positions, we're going to create one that's going to start at -7. I want -7, 0, 0, and another one that will start at 7, 0, 0. So player 1 will start on the left side of the screen. Player 2 will start on the right side of the screen. We want to add a couple of rotations. So we want 0, 0, -90. And we want 0, 0, 90. We need an explosion prefab. Actually, I'm going to go ahead and drag this into our prefab. Okay, so going back out to our 2D space kit prefabs, there is an explosion prefab. I'm just going to drag this into the scene. And I think that should be fine as is. So I'm just going to drag that into our prefabs folder as a new prefab. And I'm going to delete it from here. And so explosion prefab on our SpaceWar player. Let's just, why did I have that? Oh, I dragged it into the wrong folder. Let me delete that. Drag that back into here. And then I'm going to drag it down into this prefab folder as an original prefab. Okay, so now going back to our SpaceWar player, drag that explosion right to there. I could have assigned it from the 2D space kit, but then if we ever want to go and delete this package, we don't have any dependencies on there. What else do we want to do? I want to do a little work on our scene here. I want to add a background. We've got this art here. We have this space background 1. I want to just drag the space background 1 into the scene here. I don't want it there. I want it down here. And I'm going to rename it to background. And I'm going to move it up under the game starter here above the UI. Now, you notice it doesn't quite fill the whole screen. So I'm going to go up to the transform. And I'm going to set it to like 1.3, 1.3 on the X and Y. And you can see that now fills the entire screen. So I think that's going to look quite a bit better. And I'm going to set our player to be at -1 on the Z-axis so it shows up in front of the background. I think that looks a lot better. And I'm going to go ahead and apply that to the prefab. Let's go ahead and create our black hole. So we're going to just drag this black hole image into our scene. And again, we want it to be part of the SpaceWar scene. And we're going to again want to move this to -1. And we want this to be GravityWell. And we're going to want to add the GravityWell script and add a network object. Okay, in the affected layers, we're going to want player 1, player 2, and their projectiles. So come in here and say player 1, player 2, player 1 and 2 projectile. And I think all these other values are fine. We're going to want to add a circle collider 2D, but that's way too big. So we only want things to get destroyed if they actually get sucked into the center of the black hole. So I think that looks pretty good. And that also, of course, should be set to isTrigger. We're going to want to add a rigid body 2D and set it to kinematic. And I think that is good. So the GravityWell script will make sure that that rotates and it will handle any collisions, and it will also register with attractable objects and then pull them in towards itself. And if anything collides with it, it will destroy it. And we might as well make a prefab out of that, even though we're really only ever going to have the one. Maybe in your game you might want to spawn these randomly in places or something. I don't know. And just for the sake of my hierarchy, I'm going to move this up just above the background. Okay, so there's our black hole. And of course, I don't really want a fighter to be a default child of the SpaceWar player because we're going to add that programmatically. So I'm going to go ahead and apply that to the prefab. And let's go ahead and duplicate this fighter. Make sure everything looks good on there. And we're going to create a couple more fighter prefabs. So Control D to duplicate, Control D to duplicate. And I'm just going to rename that to Fighter 2 and Fighter 3. So let's look at Fighter 2. And the main thing that's going to be different is going to be the sprite. Instead of Fighter 1, we're going to use Fighter 2. But that means our collider is probably not going to be right. Let's see. It is not right. So what we can do is just click reset. And now our collider matches our sprite. The other thing we need to do is, we have our engine exhaust. We actually have two of them. And this ship only has one engine. Just for design purposes, I'm going to temporarily drag this onto our player. And then I'm going to move our player over to the side here. Okay. And let's look at the exhaust. So we only want one engine. And we want to move it to right about there. I think that should probably look good. Okay, and then we can go ahead and apply that and then delete it from our player. And let's take Fighter 3, drag it onto our player. We're going to go into its sprite. We're going to change it to Fighter 3. We're going to go into its collider and say reset. Let's just go ahead and double click that. That looks good. Okay, so now let's look at his. He's got 4 engines. So let's take our engines. Let's take this one. And let's move that one over there and then up a little bit. And then let's duplicate that. And we want to basically, if it's a negative, we just want to say 0.276 to put it on the other side. Then we can take this one, and that one looks fine. So let's just duplicate it and then set this to negative. And I think that should be good for the exhaust for that guy. So we can go ahead and say override, apply all, and then delete that from the player. Okay, so I think we have all the prefabs that we need. So we can now go back to our SpaceWar player and expand the SpaceWar player script. And then under Fighter Prefabs, we can drag in Fighter 2 and Fighter 3. So I think those are good. And I'm just going to apply all. And I'm going to delete both of these guys from the scene. All right, let's go into our NetworkManager and our Bootstrapper. And we're going to replace this Othello player with a SpaceWar player. And we're going to delete this Othello network prefabs. And we're going to want to create a new default network prefabs. And we're going to double click that. And we're going to go ahead and, let's see, I'm going to move Black Hole up here. I'm going to move Projectile up here. And I'm going to move SpaceWar Player up here. And then I'm going to come down here and I'm going to delete that and delete that. And actually, we don't want Network Player, but what we do want is Explosion. There's 2 of them there. So let me go into our prefabs and just drag Explosion into here. Okay, let's look at some of our other things in here. This should all be fine. This should all be fine. 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 Okay, so this is going to be something we want to change. We don't want to use the Othello game session initializer and cleanup. We're going to want to create some specifically for SpaceWar. So let's take care of that next. So to take care of this, let's go ahead and remove this script and remove this script, which of course breaks both of those. And we're going to go into our scripts folder and let's just double click one of these, come down to the bottom of our script and say public class SpaceWar game session initializer. And we're going to hit Alt Enter, move to its own file, and paste in that code. So we're going to call the base class on our game session initializer, log out some text into the debug console, and then we are going to call our project scene manager and set up our scene management and load our game scene. So And here, we load the menu scene. And then if we're not the server, we're just going to log this and get out of here. Otherwise, we're going to verify our scene. We're going to subscribe to the onload event completed, onload complete, onload event. I always unsubscribe before I subscribe. I don't always do it, but it's a good practice to do this just to make sure you don't subscribe more than once. And you get this will get called twice, and you don't want that to happen. And then we're going to load our game scene, which we use a coroutine to load this asynchronously. So we're going to load the menu scene, and we're going to load the game scene. And this basically is just us to check to make sure that our scenes are valid before we actually go ahead and load them. Load scene async. We're going to do a yield return. So this is an IEnumerator, basically a coroutine. We basically just want to do this in the background so we're not blocking the UI thread. And we do some stuff. We just want to handle when the scene gets loaded. And these are things that are all done in the Project Scene Manager. You can dig into this if you want to, go a little deeper. But basically, we just want to make sure that things are all set up correctly when our scene loads. And so we're calling that from our setup, our SpaceWar Game Session Initializer class. Let's go ahead and create SpaceWar Cleanup and move that to its own file. And this actually isn't going to do anything. We're going to derive from the base class, but we're not actually cleaning up anything. So let's go back into Unity and let Unity recompile. Make sure that we're on our Game Session Manager class, and we're going to drag in the Session Initializer and the Cleanup class, and then we're just going to drag them into their respective fields in the inspector. And for max players, we only want to have 2. All right, let's go ahead and hit Control-S to save everything. We're going to remove this scene. And I think we may actually be ready to try and test this out. Actually, before we can test, I just want to double check a few things. So let me go back into Prefabs, actually Scenes. Let me collapse that. And let's go ahead and additively load back our... So let me just double check a few things here under Game UI. We're going to want a new SpaceWar Game UI. We don't want to use the one that we were using for Othello. So I'm going to remove that. And under Scripts, I'm going to say Create Scripting, Model Behavior Script, SpaceWar Game UI. Let that recompile. And go ahead and drag that onto our Game UI object here. Double click that to open it up in the editor, select everything, and paste. So let's come over here. So we got serialized field for the player names, player scores. We're going to have get ready text, winner text, time remaining text, a game over panel, a rematch button, and an exit button. We're going to grab references to our SpaceWar Game Manager. We're going to do it the same way we did in the other class, where we're going to have a getter that will, if it's null, we're basically going to go try and find it, and then we're going to return that. Okay, looks like I have a local player index that I'm not using. So let me just go ahead and remove that. So in the start, we're going to enable our get ready text. We're going to find our SpaceWar Game Manager. And we're going to hide the game over panel. And we're going to subscribe to events, and we're going to add our button listeners. So in late update, if we have a game manager and our SpaceWar players is not null and there are more than 0 SpaceWar players, then we're basically going to iterate through all of our players, and we are going to grab that player from our collection on the game manager, and we're going to set the player's name text here. And if we have a time remaining UI element, we want to set that. And then we also want to go through all the players and essentially get their scores and assign that to our UI element for their scores. And subscribe to events, we're only going to subscribe to the game state changed event. We're going to add button listeners so we can rematch or exit the game. And I'm removing the listeners before I add them just to make sure we're not subscribed more than once. The exit game is simply going to call exit game server RPC on the game manager. And here is our handler for the game state changed event. So in game started or restarted, we're going to hide the game over panel and show the get ready text. When a player is killed, we're going to initially hide the game over panel and show the get ready text. When a player turns start, we're going to hide that get ready text. And then if the game is over, we're going to show the game over panel, which basically all we're doing here is getting the panel and setting it to true and hiding or zeroing out the game winner text. So at some point, we're going to want to determine who won the game and display something there that says, oh, so-and-so won the game. Let's jump back into Unity. And we want to populate all of these fields here. We're going to have to add some UI elements for things, and then we're going to populate these fields. So the ones we can do already, we have get ready text. We don't have a winner text. We want time remaining, so we're going to have to add that. We do have a game over panel. So there's our rematch button. There's our exit button. And there is our winner text. So I guess the only thing remaining is we need to add a time remaining field that we can display up here. So let's go up to our game UI here, right click, UI, Text Mesh Pro, and we're going to call it time remaining. And I'm going to move it up to the top of the game UI. And we collapse that. So we want to use the arcade font. We want the size to be like 48. We want it to be centered. Cap line. All that looks good. Just give it a default value of 2. We are going to want to anchor it to the top center. 85. I think that looks about good. So there is our time remaining text. So now if we go back to our game UI, I can drag time remaining into there. All right, Control S to save. Do we have everything? I know we want to go back to our main menu canvas and go ahead and turn that background on. And hit Control S to save. Go ahead and remove this scene. Go ahead and remove this scene. And I think we may be ready to try and test this. I'll be amazed if everything works and if we didn't miss anything. So let's go into multiplayer play mode. Go ahead and activate that virtual player. Switch over to my multiplayer play mode view so you can see both sessions. And let's click play and see what happens. Okay, so the menu came up on both screens. I think that is very interesting. We want this to be 900 by 600. Oops. There we go. Player 1, player 2, host, join, start, and we got a bunch of errors in the console. So we're going to have to fix that. But you can see that our black hole is spinning, so that looks cool. And we do have these 2 players over on this session, but not in the host session. But yeah, we need to fix this error here. So we're not able to find our SpaceWarGameManager in scene. So let's fix that. So let's switch back to this view here. I'm going to go ahead and disable that virtual player. And let's look at the error in the console. So this is being thrown by our SpaceWar Game UI. It's not able to find the SpaceWarGameManager, which the script obviously exists. So let's take a look at our scene. And we're still using the Othello Game Manager. So let's go ahead and remove that and go into our scripts and drag the SpaceWar Game Manager into here. Go ahead and remove this scene, save everything, go back into multiplayer play mode and then activate that virtual player. Go ahead and start the game. We're still not seeing the fighters on this side. And I'm not getting sucked into the GravityWell. I do blow up if I hit it. So we have a few things to debug here. So let's go back to this view and disable our virtual player again. And let's just look at things and see if we can figure out what might be going wrong. I'm going to reload these scenes. And let me just examine stuff and see where we might have gone wrong. Let's start by taking a look at the SpaceWar Player Prefab. And I can see right away one thing that's wrong here. We need the Attractable script. But that does not explain why we weren't seeing the fighters show up on this side. And I've got to believe that they're actually being spawned, but we're just not seeing them, which means that we're not handling the event to show the fighter visuals. That's what I'm imagining is going on there. So I suspect something might be going on in here. But to debug this more, let's just go ahead and remove this scene, and just want to confirm that I did indeed save that prefab with the Attractable. I did. Okay. So go ahead and go back into multiplayer play mode and enable that virtual player and give it a shot. So I expect to see the same behavior where the fighters are not being visible on the host, but I do expect that the fighter will be sucked into the black hole if I get too close to it. Yep, so we don't see the fighters here. We do see them here. I'm still not being attracted by the black hole. It's very interesting. Let's take a look over here. It's interesting it spawns the player under the main menu scene. Yep, so they're there. They're just being displayed off the screen. I think I know what I need to do. I think what I need to do is in the prefab, because we're spawning them at the spawn position, and the spawn position is at 0 on the z-axis. I think I want to change the spawn position to be -1 on the z-axis, and then they'll show up. But that still doesn't explain why we're not being attracted to the black hole. So we look at the console. It's interesting. It says it's applying force toward the GravityWell, but it doesn't seem to be doing anything. Very interesting. But let me go ahead and fix the spawning issue. So temporarily deactivate that. Go into our prefab for the SpaceWar player. Go to the spawn position and set this to -1 on the z-axis. And go ahead and re-enable multiplayer play mode. And I just realized you couldn't see what I was doing because I was on the wrong screen. Basically, I went into the SpaceWar player and I changed the spawn position to be -1 on both of these axes here. Go ahead and give this a shot. And there they are. Oh, we need to add an audio. Ooh, he got sucked into the black hole, so it definitely worked for that ship. And now I seem to have locked up. Because we're missing the explosion prefab on this network object component. Okay, so a couple more things to fix. So let's see if we can figure out what's going on there. We go and look at our explosion prefab. Drag that up there. Okay, I see a couple of things that are a problem. So there's this particle system destroy, let me go ahead and remove that component. And what I want to do is I want to create a couple more scripts in here. Let me just go ahead and open up one of these, go down to the bottom of our class, and I want to create a script called NetworkPS-destroy and move that to its own file and then paste this code in. So basically, if we're not the server, we want to do nothing. Otherwise, we want to grab the particle system and check to see if it's still running. And essentially, we're going to do this invoke, which says, after this duration, execute this function. So it's going to take the duration of the particle system, and then when it finishes running, it's going to call despawn object here. And then again, if we're not the server, we'll just return. Otherwise, go ahead and refactor that. If we have a network object and we're spawned, despawn it. So that's one thing. The other problem, which was what the error was, is we don't have, it's got to wait for Unity to recompile, we don't have a network object on our explosion prefab. So we want to come in here and add a network object. And I think that will fix that bug that we were seeing. So let me go ahead and go to multiplayer play mode. I'm going to deactivate, and I'm just going to say save project, and then I'm going to reactivate that and start the game. And there we are. Boom. Okay, so that's all working. Ah! That GravityWell is tough. We're not displaying our score, so we're definitely going to want to fix that. Another thing I want to double check, let me go ahead and deactivate the multiplayer play mode. I want to go take a look at our fighter prefabs. So we duplicated our prefabs, and it's quite possible that our duplicates are referencing the wrong collider. So I just want to make sure, well, we got Fighter 2, so that's fine. Shiprunner, Fighter 2. So maybe that is all okay. Okay. I thought maybe that might be an issue with why the ship on the client was not being dragged toward the GravityWell. We still might have that issue, but let's look at why we're not displaying the score. Actually, before I do that, let me add our sound effects here to the projectile. I want to have an audio source. And for our clip, we're going to go into our free laser sounds pack. And I want Light Blast 2. And it will play on awake. We don't want it to loop. And save that. And then let's go into the prefab for our explosion. Add an audio source. Expand that, and for our clip, we're going to go into sounds and drag this distant explosion sound into there, and again, it will play on awake. So now at least we'll have sound effects. Let's see if we can't figure out what's going on with our UI though. Go up to our scenes, additively load the main menu, additively load the SpaceWar scene, and take a look at our UI here. So there is the scored text, and there is the player name text. Yeah, so first of all, I don't really like the placement of those. Let me take this whole thing. Let me just put something in here so I can see it. I'm going to say player 1, and then for score, I'm going to say 0. And let me just, first of all, drag this up somewhere about there, I guess. We obviously don't want that font. We want the arcade font. That should all be good. Looks like it's a little bit big. That should probably be good. And then for the score, we also don't want that font there. We want to use the arcade font. That all looks fine, fine. But that location is terrible. So let's just do center and position that down a little bit below, like that. I think that probably looks okay. Again, this is a little wide. Okay, that's probably fine. I'm just going to duplicate this, and I'm going to delete that one, and then I'm going to rename this one to Player 2, and then I'm going to set this to 721, so it's over on the other side of the screen. And we need to drag those guys into here. So Player 1 text and Player 2 name text. Go ahead and collapse those. And then the player scores. And now we should be getting our UI displayed correctly. So go ahead and minimize that or remove that and remove that. And we should be just about ready to try and test again. Fire up multiplayer play mode again, activate that virtual player, start the game. I'm going to turn off sound on that session. So now we're only getting sound from this one. So let's see if screen wrapping works. It does. We're not colliding with the other ship. We're going to have to fix that. The shots go through the screen. So the score is working. But this player is not getting sucked into the GravityWell. I wonder why. I collide with it, but I'm not being attracted to it. So what I'm going to try and do, I'm going to stop the game and then start it again. And this time I'm going to host the game from the other session so I can debug it on the client side and see if I can figure out why he's not being attracted. I'll make this one player 2, this one player 1, this one will host, this one will join, and this one will start. So again, the client player is, well, that's interesting. So this is the host. Okay, yeah, so the host was attracted. All right, let's try it as a client. Okay, so let's pause this and let's take a look at player 2. It has the Attractable script. The player layers are not being set correctly. So that is a problem. Let's diagnose that and figure out why the player layers are not being set correctly. Because the GravityWell, as we know, is only affecting certain layers. Let's go take a look at our player prefab and look at the SpaceWar player script. In an on-network spawn, we're setting the player layer if we're the server. Let's move this outside of that if statement. So we're only going to randomly assign the fighter index if we're the server, but I think we want to set the player layer regardless. So it's going to look at our connection ID, and we're either going to be player 1 or player 2. All right, let's go ahead and rebuild and see if that doesn't fix the problem. We are on the correct layer. But we are still not getting attracted by the GravityWell. At least not that I can tell. The good news is when we got down to 0 time, it went to the game over screen and I could rematch or exit. So we could play again. Definitely not being attracted by the GravityWell. Let's see if we can figure out what's going on there. So we should be getting a log message whenever something is added here. So I'm going to see debug.log register Attractable on GravityWell. And then I'm also going to display whether or not we are is server. And then here I'm going to say debug.log registered. So we know, oops. So we know that that got registered there. And in update, we can say debug.log attracting Attractable. And let's just go into here. We're already logging that. You know what? I think what I might want to do is if rigid body and not rigid body is kinematic. Oh, is kinematic is obsolete. I should use body type. All right, so we only want to use this method if we're a non-kinematic rigid body. So let me come over here and say and then down here, just to get some more information about what may or may not be happening here. So first of all, let's just look for attract. Huh, that's interesting. So it's interesting on the server, we are definitely getting the log messages for the GravityWell, which makes sense because that's where the activity should actually be applied. So player 2, player 1. So let's just see what happens. Okay, so it says it is applying force to this guy's rigid body. But it does not seem to be having any effect. And then the game is over. Noticeable effect. I think I know what's going on. If we go look at our prefab for the SpaceWar player and we look at the network transform, you can see the authority mode is owner. So only the owner can move this guy. But we're trying to apply this attractable behavior on the server. We've got this if not is server return. So I think what we need to do instead is make this an RPC on the client, and then we can call this from the server. So let's see here. We'll call this one RPC. And we're going to want to make send to owner. And we want to have public void attract. Yes. And here we can say if not is server return. And I think this should do it. That doesn't need to be public. Let's give that a shot. So save project, enable that virtual player, start the game. Player 1, player 2, go ahead and host it over here, join from over here, start over here. And we get sucked in. All right. I believe it. I believe that it is working as designed. Okay, now that we've got our game working, we want to deploy it so other people can play it. So what we're going to do right now, we're targeting Windows. So we're going to go into our build profiles and we're going to switch to web. And we want to go to our player settings. And in here, I'm going to put Midnite Oil Software LLC. We can maybe just call this SpaceWar. You got your version. I recommend this resolution using the default template for WebGL. For the splash image, if you want to, you can say don't show the Unity logo, but you could add, if you wanted to, your own background and logos. So for my logo, I think I'm going to select splash screen. And then for a background, let's see. Something like space background 1 should be fine. Yeah, that should be fine. Other settings, I think all of this looks fine. For publishing settings, you want to make sure you got Brightly compression set. I think all of this stuff is fine. So once we've done that, you go to your build profiles and say switch platform. And this is going to take a little while. So while that's doing that, I'm going to jump over to our browser and I'm going to show you my itch.io page where I've already deployed this game, but I'm going to show you how you would go through this process of doing this. But in the meantime, I'm going to show you what my settings look like on this one. So when you create a new game on your dashboard on itch.io after you create an account, you give it a title. It will automatically populate the project URL based on what you call this. You can give it a description. You can give it a classification. You do want to say that it's an HTML game that can be played in the browser. And then this one says in development. After I get done this video, I'm going to change this to released. But right now it's in development and I've got a password assigned to it so only people with the password can play it. When your build is done, after we've switched our platform and we've actually done a WebGL build, you're going to do upload file and you're going to upload a zip file. So after my build gets done, we're going to zip it up and then upload it. And then you can say whether or not you want a full screen button. You specify the viewport dimensions. So I like to make it a little bit shorter than the actual size. And we can do embed in page, manually set size. And then whatever you want in the description. I just put a bunch of information I thought was useful since this is part of a tutorial, and I will put a link to the video in here after the video is posted. And I did use some AI to generate some stuff in this game, so I wanted to indicate that. itch.io likes you to do that. Give us some tags, whether or not you want people to be able to add comments. And then when you're done, you would click Save, and after you save, you can say View Page, and then you could actually test this in the editor, and it will load up. And there's my little splash screen. You see my background there, and boom, we are in the game, running on itch.io right in my browser. So now that we are still changing our platform, I'm going to pause the video, and when this is done, I'm going to come back and show you how we build this and deploy it. All right, it finally switched platform. So now what I'm going to do is build, and we're going to specify a folder for it. So I'm going to come up here to Midnite All Software, Tutorials, Builds, WebGL, and I'm going to create a new folder and call it SpaceWar. Select that folder, and it's going to build a WebGL build to that folder, and that's going to take a while. So as soon as it's done, we'll come back and I'll show you what to do with that build. Okay, it finally finished building. And so if we go into our SpaceWar folder, you can see we got this index.html, we got our build, streaming assets, and template data. I am going to use 7-zip. Use whatever you have at your disposal to create a zip file. I go into show more options, 7-zip, add to spacewar.zip, and there is our zip file. So now I'm going to copy this path here and go back into my itch.io web page and say edit game, upload files. I'm going to paste in that path and select that zip file. Let it upload and then click save and view page. Loading game for the first time and click run game. And there we go. So I'm going to open up a completely different browser, Firefox in this case. And I'm going to bring that over here. I'm going to run the game over here. Host, join, start. Well, kudos to you if you hung on for the full 2 hours. And I realize this wasn't my most polished video, but I think it's good to show the mistakes so you can see how the sausage is actually made. And I hope you still found it useful. And if you did, do me a favor and click that like and subscribe button so we can get this content in front of as many people as possible. Thanks so much for watching, and good luck on your game development journey.